Hello, my name is Manshwari Segran. Today I will be present um, on my project titled Wavelet-Based Features and Generative Adversarial Networks (GANs) for Image Forgery Detection and Localization. Moving forward to the chapter 1, imagine a dynamic duo in the realm of image manipulation detection, that is wavelet-based features and generative adversarial networks (GANs). Wavelet-based features are like detectives of the digital world, where it is skilled at capturing both local nuances and broader picture of details within images. Their versatility makes them perfect for um, spotting the what we call as forged areas. The GAN's generative adversarial networks is the shapeshifters of the AI world. Picture them as a two players in a high-stakes game, the generator and the discriminator. The generator creates fake images while the discriminator tirelessly hunts for the flaws. Next, we move to the problem statement. The research aims to address the problem of image forgery detection and localization. It is known that image forgery is a prevalent issue in today's digital age, where it is edited or manipulated images can be can be easily created and shared. Um, Not just that, this poses a significant challenge in various domains, including journalism, forensics, and social medias. In order to uh, solve the problem statement, we have we have come up with a objective um, where our objective is to develop and optimize the wavelet-based feature extraction techniques with the aim of enhancing the accuracy and reliability of image forgery detection. Second, to implement generative adversarial networks (GANs) for the generation of realistic forgery samples, which will be utilized for both training and testing purposes. And third, is to systematically evaluate and validate the robustness of wavelet-based features and generative adversarial networks in detecting a diverse range of image forgery types and manipulation techniques. Our main object, our main motivation uh, is to revolutionize image manipulation detection by addressing current method deficiency. Conventional approaches miss the mark by focusing solely on global features, neglecting the intricate dance of local features. Entering the wavelet-based features, our secret weapon in uncovering hidden nuances across the spatial and spectral domain. Mm, and then our next motivation is to extend the bridging gap in deep learning models, injecting innovation by harnessing GANs to construct mask decoders for pinpoint forgery identification. Uh, then the research gap is we have divided into four, where the existing landscape aspect is to dominate the global features, where to ignore the crucial local nuances. It was found on the Al Quraishi and Ramli study. Second, addressing the gap, we we unleash the power of the wavelet-based features for local relationships. Third is the GAN's utilization, where the GANs tapping into the detective role, constructing mask decoders, and the gap, bridging the gaps where the SVM support vector machines classifiers are as a precision architects and closing the local feature gap. Research question. Research question. Hmm. One of the research questions that arises: how can the integration of wavelet-based feature extraction, generative adversarial networks (GANs) for mask decoding, and support vector machine (SVM) classification enhance the accuracy and precision of detecting mm, and localizing forged images by emphasizing relationships among local features within tempered images. Okay. To reveal this question, our question emerges from this exploration seeking to unlock advancements while addressing crucial gaps hindering accurate forgery identification. Um, First, the unraveling the puzzle. Okay. Unraveling the puzzle. We are delving into methodologies for precise localization of tempered uh, regions using SVMs, leveraging insights from pioneering research on feature extraction and forensic analysis. Second, the synergistic potential. Synergistic potential, but here's the twist. Our approach isn't just about one technique. It's a synergy of wavelet-based features, unique GAN applications, and robust classification methodologies like support vector machines. They aim to revolutionize forgery detection, accentuating local feature relationship and boosting the precision. That is the innovation in action. In essence, our research question mm, drives an exploration into the transformative potential of advanced techniques tailored to enhance the accuracy and precision in identifying forged images. This is thorough of the chapter one that is on introduction. Next, we move to the literature review overview, where it uh, divided into two parts, of image forgery detection that are active approach and passive approach. Active approach divided into two sections, where it is the digital marketing and digital signature. And another passive approach is based on tempering, which subsection into three: copy move, image splicing, and image retouching. Okay. These methodologies of literature review leveraging the machine learning, deep learning, and computer vision. Active approach is simply digital watermarking that is to detect the see that is to detect seeing the image is watermarked or not. Passive approach, followed by tempering, which is of three types: copy move, image splicing, and retouching, um, is one of the common detection techniques to identify regions in an image that have been copied and pasted. Then we go to the machine learning and deep learning methods. These methods are included in the field of image forgery detection, where the machine learning and deep learning methods have shown the promising results. These methods involve feature extraction, machine learning techniques, and the use of support vector machines, SVM, and convolutional neural networks, CNNs, for accurate detection and localization of image forgeries. What is the significance of uh, this deep learning and machine learning methods? It is to first, it is to feature extraction and machine learning techniques. To yeah, for it is crucial for extracting discriminative features, enhancing detection accuracy. Second, support vector machines network is important to robust classifiers capable of distinguishing between authentic and manipulated images. And third is CNN, convolutional neural networks, where the deep learning methods adapt at learning hierarchical features, leading to state-of-the-art performance in forgery detection. We go to the next. This is the part where the feature extraction and convolutional neural networks were divided. Feature extraction is basically on the wavelet-based features that have been widely used for image forgery detection. This is the capture of the characteristic of different frequency bands and can help identify manipulated regions in an image. Feature extraction includes only the input image and convolution process, while the classification includes the every process that are um, input, convolution, pooling, fully connected, and output. While the CNN, convolutional neural network, can automatically learn hierarchical representation of images, enabling them to capture complex patterns. In this picture, in this figure 2.7, the feature extraction only includes of input and convolution. If the classification uh, um, plus with sum up with input, convolution, pooling, fully connected output, that is known as a convolution neural network process architecture. Next is a support vector machine. In my project, the support vector machine is most important part. Why? Because it is supervised learning algorithm, where it can be trained on labeled datasets to classify images uh, as authentic or manipulated images. This algorithm learn the patterns and features from the training data to make accurate predictions of unseen images. As we can see, figure A is the SVM classification, while the this Gauss figure is uh, classification accuracies for the generative adversarial networks. Wavelet-based transform techniques is divided into two sections where it is spatial and spectral. Spatial is a spatial domain analysis where it is consists of a multi-resolutional insight. It is to mainly decompose images into multi-resolution representation, unveils local and global features. And the second is a nuance detection, where it is offer insight into image structures across different scales. While the spectral domain analysis includes of frequency component analysis, where it is to extend the wavelet transforms into the spectral domain enhances sensitivity in forgery detection, while the image identification enables the detection of frequency-based signatures indicative of tampering. Guns in a forgery detection is divided into two, where it is generator and discriminator. Generator mainly for to create images, and discriminator is to to enhance the performance of forgery detection and localization. Training process for guns. In the training process of guns, there are adversarial training and dual order attention. Guns for image manipulation detection. There are limitations. That is, the guns may struggle to detect and localize image manipulation, and guns of interpretability may lack the interpretability where it is difficult to understand the specific characteristic that indicate image manipulation. Next is the tools and software integration, where to perform the image forgery detection and localization, this project this project finds that some of the studies utilize a combination of wavelet-based features and generative adversarial guns of such wavelet transform, generative adversarial guns, Python, TensorFlow, and OpenCV, while the evaluation metrics include the precision, accuracy, and loss, and benchmark dataset usually on CASIA2 datasets. Then the state of the arts. SOTA wavelet-based features achieved an accuracy of 92% in image forgery detection, and the guns, generative adversarial guns, have shown the promising results of accuracy of 95% in detecting and localizing image forgeries. We can see in a proof of the pictograph histogram below. Uh, that's all for chapter 2. Thank you. This is the state of the art table SOTA, where uh, where some of the studies of Farid H entitled Image Forgery Detection, a comprehensive review, is on the technique approach, on the review of the forgery detection technique. Mm, Main contribution is to comprehensive review and using the variety data sets such as CASA, SURF, and Akaze, and others. The metrics includes the accuracy, precision, and recall. And the tools were used was MATLAB, OpenCV, and M5. Programming language used uh, in this research is MATLAB, Python, SVM, and second is the deep learning for image forgery detection of Bayer, or where it is used to extend the review of deep learning methods by using the Python and CNN. Third is the Al Quraishi Ramli of 2021. It is on a survey on image forgery detection techniques, current challenges, and future directions. The technique approach is to survey on image forgery detection. That is used F1 score, ROC, AUC, and the last uh, research is on the local feature based watermarking techniques for printed visual images from Swaminathan et al. In 2022. It is focused on printed visual images. Thank you.